Students, this is Mr. Ivan. Many of you are texting me to say that you're very worried about real-world application question, which is the last question of paper 2 in your Emath O-levels. Okay, so I've picked 3 types of real-world application questions to discuss with you today. Okay, so this is the one that involves graphing, which similarly came out in the 2018 O-level paper before. Okay, so it says that a right circular cone of height. So once you have this kind of information, okay, so best is always to label. So this is 5 plus x, yeah, is in a sphere of center O and the radius 5. Now, when you see a sphere, the most important thing to know is that when you have a sphere, any point from the sphere to the circumference is called the radius, and the radius is how many? 5. Okay, now important thing is, number one, you want to find the volume of the cone. What is the formula of the volume of cone? So volume of cone is 1. So volume of cone is equals to 1/3 pi r square h. Okay, what do we have? Do we have the height of the cone? Yes, we have, but we do not have the radius. So very important is, when you see a cone, you must always think of triangles. And what are 2 important things for triangles? Sometimes you may need to use similar triangles. Okay, let me digress a bit. So let's say it could be something like this, you see, where this is the radius, and probably they may have given you something. Let's say this is 5, okay, and then this is your h, and then this is your, maybe 10. Yes, okay, you may need to use similar triangle where r over 5 is equals to h over 10, yeah, to take r away, okay, because if you look at this over here, this formula over here, there's only x, there's no h, or there's no r, okay, there's only one variable. Whereas in a right angle triangle, you always usually, or rather when in a cone, you usually have 2 variable where there's a r and there's a h. Okay, so this is just a little bit of digression. Okay, alright, now in the case of this, can you see the right angle triangle? It is over here. Okay, so if this is 5 and this is x, this is the radius of the cone. So by Pythagoras Theorem, r is equals to square root of 5 square minus x square. Okay, yep, and that's how you get then in r square it will be equals to 25 minus x square. Alright, so for this cone, it will be 1/3 pi. The radius is 25 minus x square, okay, and then the height is 5 plus x. Now we have to incorporate a little bit of algebraic identities here. Okay, 25 minus x square is 5 plus x, 5 minus x, and then you have a 5 plus x behind. That's how you get your 1/3 pi 5 minus x bracket 5 plus x square. Okay, why? Because of algebraic rule number 3. Alright, your 25 minus x square is equals to this and this. Okay, so after you have proven this, showing is actually the hardest part, because once you have to show, okay, you can roughly formulate the equation already. If you cannot show, you cannot start anything at all. Number 2, explain why the x must be between 0 to 5. Okay, that is because, so how do you explain? Now, since always use words like since and therefore to explain your mathematical argument. Okay, so you can say that since, okay, 5 minus x, alright, 5 minus x must be greater than 0. If not, the whole volume will be negative, okay, and we cannot have a negative volume. So then you have this, x must be smaller than 5, alright, and okay, x must also be greater than 0 because x is a length, so therefore x is greater than 0 and smaller than 5. This is how you explain. Always use since and therefore to explain your mathematical argument. Alright, next is team wants to use the cone. This is a question I set myself, okay, of at least 120 cm cube. So when we look at 120 cm cube, we are talking about volume. So he says that the volume must be at least 120 cm cube. So how do we formulate? Okay, she wants the curved surface area. So now we're talking about two things. We have a volume and we also have a curved surface area over here. Now look at your equation. Your equation is V is equals to 1/3 pi 5 minus x and 5 plus x squared. There's nothing new that you have. There's nothing new in real world application. It's always talking about things that you have learned. Alright, so what do? We go and plot the graph. Okay, so before we need to plot the graph, we need suitable values. We need to have an input output table, isn't it? Okay, so what is the input output table? Okay, x is always the input, v is always the output. What are the values of x that we use? We always look at this inequality here. We can use 0, no problem. We can use 1, 2, 3, 4 and 5. Okay, so now we sub in x equals to 0 into your calculator, x equals to 1 into your calculator, x equals to 2 into your calculator, x equals to 3 into your calculator, and we plot the graph. What is the graph that we plot? We plot this. Okay, v is always on your y-axis, x is always on your x-axis. This is how we tackle questions like this. Okay, always use the formula that they ask you to prove, okay, to draw into a graph. Okay, and then after which, what will you get? You will get a graph that is something like this. Okay, sorry. Okay, so you will get a graph that is something like this. So what did the question say? The question says that she wanted to be at least 120. So which means the volume is equals to 120 cm cube. Okay, V represents your y-axis. Y equals to 120. Where would that be? So that would be, take your ruler, measure 120. So 2, 4, 6, 8, 10, and that would be here. Okay, and we draw a line. Okay, and then this is where V is equals to 120. Alright, and when after you draw V equals to 120, what do you think is the most important? We always look for the point of intersection. So over here, you will have 3.3. This means that, so how do you present? Again, is when V equals to 120, your x is equals to 3.3. Yes, and that is how you get that value of x from using the graph. Okay, so looking back at the figure, we want to have, or rather the question, we want to have the surface area of the cone. Surface area is pi r L. Okay, so surface area equal pi r L, which is equals to pi times your radius is 5. The radius of the cone is 25, square root of 25 minus x square. Okay, square root of 25 minus 3.3 square. Okay, and but what else do you need? You need the L. L is the slant height. This L is the, you need the slant height of the cone. So how do you get it? Okay, I'll draw the cone here. Okay, so this is, okay, this is the center, and they say that this is x. okay, which means that this is 5, okay, and then this is your R. Alright, so you got to use Pythagoras Theorem to find that L square is equals to square root of R square plus your X plus 5 bracket square. Find out the value, sub it inside, and that is how you get your surface area. Okay, so the most important thing is when you see a real world application question, do not panic. Slowly work out the initial answer. The first few parts you will be able to get the answer. Usually it is about cone, or rather usually if it is about volume and surface area, so make sure you apply accordingly. Find out what is the equation that they want. If they ask you to draw the graph, okay, let the V be the y-axis and let the x be the x-axis. Draw a graph, input the values that you want. Okay, there's no wrong values. If you want to put 1, 1.5, 2, 2.5 is also perfectly okay. All right, always use the inequality to put in the input values, and then plot the graph, draw the line whereby they want the volume to be. Find the value of x using the graph. So the important point of this question is you must find the x, right, from the point of intersection. Okay, and once you get your x, you can just put it in to do the other parts of the question. All right, good luck.